Hi, everyone, guys. I hope that you had a good break. So funny fact before this presentation, so when I submitted this topic to this conference, I didn't expect to have the creator of MobX here in the room. So if you have any question, or I say something stupid, ask to Michel, because he knows better than me, for sure. So that's the first thing. OK, so today I'm going to talk about MobX State Tree and React. But before to do that, I give a brief introduction to me. So my name is Luca. I'm a chief architect in The Zone. The Zone is a platform similar to Netflix, but instead of broadcasting movies, we're broadcasting sport. Hopefully, sooner rather than later, we will be here in Netherlands as well. I'm a Google developer expert on web technologies, and I'm the community manager of the London JavaScript community. It's a meetup in London that is basically taking care about JavaScript. So what we're going to see today, so today I'm going to talk about MobX, first of all, because when you understand that, you will see that MobX State Tree is bread and butter, really, really easy. I will talk about MobX State Tree, and because I thought that maybe having too many slides could be boring. So what I'm doing at the moment, I created like a nice example that I hope that you will enjoy. And we will go through the code, and we try to understand how MobX State Tree could be applied to a web app. OK, so let's start with MobX. As you know, MobX is a state management, so there are many out there. Probably you're familiar with Redux. We just saw Vuex in the first presentation that Sarah did. But MobX is another one. And the interesting part of MobX is that it's fully reactive. And when I'm talking about reactivity, I think that Sarah provided a good explanation what reactive programming is. But the thing is, reactivity is getting a lot of traction. So I spent the last 2 years studying and researching about reactive programming, mainly for front-end, but also on back-end. And then on the back-end, I discovered that there are a lot of stuff that is already there and is well-consolidated paradigm. But on the front-end, we're still a bit weak on that side. So I'm trying with these talks. It's 2 years that I'm going around the world talking about reactive programming. So I hope that this one is a brand new talk. So I hope that you will enjoy it. So talking about MobX, the first thing that I love about in the documentation is this sentence here, because it provides the exact explanation of what we are going to achieve with MobX. Anything that can be derived from the application state should be derived automatically. That's the beauty of this, because often, and we will see during the presentation, in particular, I'm not that young, as you can see and imagine from my beard, but in the past, I approached several programming languages, and when you have to update the views or update the state and create, let's say, an architecture that was solid enough, it takes time. You can make mistakes, and then the most boring part is, in particular, when you have to maintain your code base after, I don't know, 6 months, 8 months, a year, because then you take shortcuts and everything. But having this kind of frameworks and tools that allows you to improve your code quality is very important for me, and MobX is one of them. So if we want to describe MobX in a nutshell, I try to capture the 5 key concepts that currently MobX is leveraging. So the first one is observables. So observables are used for defining the application state. And observers react to any change. So when we talk about observables, when we talk about observers, you have to create in your mind this correlation, producer-consumer. And probably it's easier to understand in this way. Because one thing that I noticed in reactive programming, the first issue that you have is the dictionary. So the word that the vocabulary that reactive programming is leveraging every day. So instead, you need to move back to your pattern, the common pattern that you use to work every day. So an observable basically is a producer. And what it does is every time that you change something, is emitting this change. And someone has to listen on that. That is the observer. If you are strong on design pattern, probably you recognize immediately that this one is based on an observer pattern. There is behind observables also the iterator pattern. So every time that something changes, we can iterate iterate through the changes, so the new data that are coming inside the observable through the time, and use them in order to update our view or doing other stuff. And in this case, MobX is really, really good to provide this implementation, because it's not making that more complicated than it should be. And MobX is one of the different frameworks that allows you to do that and work more or less in an imperative way, if you want, with reactive programming. Then we have computed values that are basically pure function that are used to derive complex values. So let's assume that, for instance, you want to take let's say, compose a string and you want to output on your UI 2 different strings that are coming from 2 different observables. In this case, you create a computed value. And MobX is so smart that it's caching what you, the final value until it's going to change. So in that case, you don't even have to care about performances too much. Then we have reactions that are used for handling side effects. So for instance, if you need something that should, I don't know, an HTTP request to an endpoint, usually you wrap it inside a reaction. And that is a nice way to maintaining the same architecture that is available on MobX and MobX is providing, and at the same time doing side effects outside this architecture. And last but not least, actions that are usually the methods that are called by the Vue in order to update the application state. So with this map model, we can basically moving safely inside the MobX ecosystem. So if we want to see, for instance, an example of this, I extract this small example. So let's start from the bottom this time instead of from the top. So usually on the bottom, what we have is just a React application that is rendering a custom component called counter. And inside there, as you can see, I'm injected a state that is counter state. And what the counter state does is providing is an observable, as we said, described before. And what is providing is 3 things. So we have 2 methods that are increasing and decreasing, and a value that is our state that is starting from 0. And then we have this @observer in front of our React component that basically is a decorator. If you're not familiar with decorators, something that is available in ES7, if I remember well. The decorators, what they do is just augmenting your object, providing some, it's like a sort of composition that is taking the object, wrap it, and augmenting its power, adding new functionalities and new stuff. That's something very well known in other languages, and starting now, we can have also in JavaScript. So it's leveraging this thing. It makes your code very, very easy because it's just augmenting this React component with the possibility to observe from an observable. So what we do basically every time that we click a button to increase the value, and what we are doing in our state, we are updating our state that is the value, increasing or decreasing. And automatically that, because there is our observer that is listening to all the changes that are happening inside the observable, we are displaying content. We are updating the view. That's really simple, okay? So nothing fancy, nothing crazy, but this is how it works. So if you want to rationalize MobX in a certain way, we can draw this simple diagram. So we have our UI, that is our views. Every time that we interact with our UI or the user is interacting with our UI, we have an action that is dispatched. This action is updating the application state, and then the application state automatically reacts to, so every time that someone is listening to this application state, is reacting to that. So like computed values and reaction, like I described before. As you can see from this diagram, what I did is just highlighting what you need to code with the red arrows, and the dotted arrows is what you have out of the box. So every time that you have a computed values described and is linked, if you want, to an observable, automatically everything is happening. So the computed value is updated, and that triggers the update of your UI. So as you can see, and this is a pattern that you will see in a vast majority of the latest framework and implementation on the in the front-end world. We have like a unidirectional flow that is starting from the view and is not going to be break. So in the past, when we used like MVC, MVVM, MVP, all these architectures, the developer has to be very disciplined in what was doing and how was handling the communication across elements. But in this case now, we have, let's say, a nice implementation that is super easy to implement. And also, if you have a lot of developers and you are spinning up new teams or adding new developers inside your team, they are picking up these things very easy. And you cannot make mistake, because the separation of concern of each single element allows you to understand immediately where the bug is, because you can debug your application very easily. Let's talk now about MobX State Tree. That is the whole point of this talk. So the definition that you can find on the website is opinionated, transactional, and MobX powered. And that's the part that I like. So what we have just seen in MobX is just augmented in a certain way in MobX State Tree. It's opinionated because it's in a certain way forcing you to think in the way how MobX State Tree is working. And therefore, so I read a few articles that Michelle wrote and other people wrote around MobX and MobX State Tree and the difference between the two. MobX is great, and they provide a lot of, let's say, a nice canvas to start to create your application on top of it. But at the same time, they provide a lot of freedom. And freedom in production code could be dangerous, as you know, in particular if you have a large organization, if you work for a large organizations. In MobX State Tree, instead, we are trying to, let's say, nail down a few concepts that we will see in a moment. And in that case, what we are doing here is just following few good practices and create our application that we be able to scale up in the case of the front end teams-wise more than user-wise, because obviously one of the main challenges we have nowadays in the front end environment for scaling is not more it's not anymore on our code, it's more on how many people can work on the same project at the same time. MobX State Tree has, let's say, 4 concepts that for me are very important. So the first thing is you can write imperative code, and behind the scene, you have reactive programming applied to your code. And that's very powerful, because if you want to approach the reactive paradigm, there are several ways to do that. There are plenty of frameworks out there. As Sarah was saying, react.js is not triple equal to reactive programming. It's inside this umbrella, yes, definitely. But there are way more outside there. There is Cycle.js, there is, I don't know, the SAM pattern, there is Vuex, and there are many others that are maybe less known, but are there. And one thing that I really like about MobX is it's perfect as starting point for approaching the reactive paradigm. Because you write normally how you always written your application. But in this case, you are leveraging the power of reactive programming, but behind the scene. So if you really, really want to, let's say, extend the possibility of MobX State Tree, you can do that. You can implement potentially also React.js, but you don't need that. Everything is already out of the box for you. Another thing that I really like is the fact that there is a check on the type that you are describing inside your model. So one thing that if you are using ES6, you're not using TypeScript, and you're not using Flow or any other tool to check what you are writing, and I know many companies and many developers that are doing that. One thing that you have is usually you need to enforce a lot on your unit test how your application is working. So with this type system, you can, you have to always do a unit testing, by the way, it's not the message here that you should avoid that. But you can enhance the experience, because at runtime, you can pick up if some other developers or you forget to, let's say, create a specific element in the way how it should be inside the model. The other thing is immutable and mutable tree with snapshot. What does it mean? So basically, it's mutable, so you can, in the model, change your values easily without any problem. But behind the scene, what MobX State Tree is doing is creating a snapshot of the tree that corresponds of your model, serializing it, and is creating that snapshot in a way that becomes immutable, your tree. So you can easily implement an undo-redo strategy without any problem, just using snapshots that are provided out of the box by MobX State Tree. And the last thing that you can have, if you're familiar with React, and I think vast majority here are, you have lifecycle hooks inside your React component. You have the same in MobX with patches that we will see in a moment and snapshots. So if you want to see how MobX State Tree works, this is literally, I grabbed this example from the MobX State Tree guide, documentation, sorry. And basically, what we have, you can see immediately how it works. So we have this types object at the beginning of this to-do store object, and we have these types that contains cascading several different objects that are model, views, and action. So what we have in the model, we are describing basically the application state. And what we have there, we can have different type of things. Like the first one, as I mentioned, we can describe that loaded, in this case, the variable, the property loaded, is a Boolean. And therefore, for sure, no one can mistake this thing because you will have a runtime error. You can have a specific endpoint. So you have a computed values where you can have like the string or a primitive inside directly on your element. You can also describe something that is a little bit more complex, like an array, for instance, of to-do. And that's interesting because it's not like a generic array. So here we are saying we are accepting inside this array only to-do elements. Or we can have a reference to something else. That in this case, it could be a to-do object. So again, as you can see, we can specify what we are expecting from this model, and that will simplify the way how you're working. In the views, instead, we are wrapping up inside there an object with all the computed values. So as I said, for instance, computed values, it should be like a pure function, so it shouldn't create any side effect. And what it does here is like completed to-dos is just filtering for all the from the list of all the to-dos, just the one that has the tick done. Action instead is what is called usually by the UI in order to update the model. So in this case, as you can see, we have few things to bear in mind. It's very simple, but it's very powerful. So if we see, we start to dig a little bit in deep about MobX State Tree, we can see that there are few as I said, it's opinionated, few caveats that we have to bear in mind. So the first one is inside a tree, you can have only one type of a specific node. So you can clone the node and, let's say, doing a copy of it, but you should have always one and only one. Any node inside the tree is a tree itself, so you can also have these trees that are completely separated between them. And the nice thing that MobX State Tree is providing you is a lot of utilities for doing composition, also from dynamically. Not only you don't need to specify your model upfront inside your application, but you can also dynamically, let's say, merge and compose your tree in a unique state tree. All the leaves inside the tree must be serializable. That's why I was talking about snapshot and patch. So the power that so MobX State Tree is immutable, because what you can do is literally automatically creating a snapshot that is basically a representation, serialized representation of your model. So this is very powerful because, as I said before, you can also have some hooks around this. So every time that is created a snapshot, you can perform some action like, I don't know, storing the latest snapshot inside your local storage, for instance. But the other nice thing is that you can also have, and I'm linking to the last step of this last point of this slide. You can have also patches. So what a patch does is a standard in JSON, and basically is providing you what is changed between the two snapshots. So if you think about MobX State Tree, like React, is the perfect companion for React, because in React we have a diffing algorithm that is doing is using the virtual DOM in order to understand what is changed. In MobX State Tree we have patches and snapshots that are doing that, and it's really powerful when you combine this element together. So what I created for this example, for explaining MobX State Tree, is this simple application. There's an image gallery. We will see live in a moment. This is the visual part. I would like to explain a little bit how I worked in order to understand this thing. So this is how our application works and how I structure, and we will see in a moment. So on the left side, we have like all our UIs, and basically we have our React application that is composed by multiple components. and is wrapped inside an application, a React application that is wrapped inside a provider. So what the provider does is a utility that is provided by a library from MobX and allows you to have, allows to inject our store inside our React application. And the beauty of this is that everyone inside these, any components inside our application will be able to pick up any part of the store. So in that case, you need to be a little bit disciplined in order, if you want to link one-to-one this element, but it's completely up to you handle this, this situation. On the other side, we have a store that is a tree, and is composed by other leaves that are, in this case, the photo gallery store. I created the search store and the selected picture store. On top, on the right, there is what I call the gallery model. So I think MobX State Tree is great. But when you work with a lot of developers that has to access the same, let's say, describe a model of your application in a way that is easy for everyone to access that, it could be trivial. Mainly because, as you can see, it's a tree. Therefore, you need to understand how is the hierarchy of your tree in order to access a specific thing. And when the things are simple like that, we have just one nested level, happy days, no problem at all. But when we start to have like multiple nested level, you never know because maybe you're working on the same application with multiple teams, you need to have some clearance on the way how you are writing code. So in this case, what I'm doing, I'm leveraging the power of MobX State Tree composition, and I'm creating a new tree that is the gallery model that will store all the things that are related to the model of my application. So the things that should be available across all the stores. This is not a best practice. This is, let's say, a real-life example. So it's something that we are implementing in our application. We saw that it's working very well because we have like 20, 25 developers that are working on the same application at the moment, and using MobX State Tree is helping a lot. Okay, so demo time. Let's go here. Can you see that? Okay, so just to be sure that everyone can see that, let's go here, and hopefully it will work. Yes, still working. So Amsterdam, why not? Okay, so this is what I built in MobX State Tree. Pretty simple. So I have immediately when I select something, an image that is displayed on the right, and when I click on another image, I'm just loading it. Okay. Easy. I have my search, fine. Obviously, I cover only the happy days, the happy path at the moment, but not all the errors and everything because it will require too much time in order to explain all of that. But yeah, that's the idea. Okay, so let's start from the beginning. So this is my application. The application is interesting because I separate it in a couple of things. So as you can see here, it's very similar to what I showed before for the counter application. So I create my React application. I decorate with, I augment my first component that is the hub component with the observer. And inside here, I have all my components that I described before in my diagram. What I'm doing here in order to link MobX State Tree with my view is using this provider here. And what it's doing is just injecting something that is called Pix Gallery Store. That is my main store that is composed by multiple other stores and multiple other trees. Well, what I have here is a few things that are important. So the first thing, as I said, I created this model that is called Gallery Model. And here I'm storing all the different things that are shared. So if we jump quickly on the gallery model, what we have here is just a tree, as you can see here, that is composed by some actions, because they are used across multiple stores, and are used by and describe some properties like that are used across multiple stores, like the search term, the picture list, and the selected picture. Also, in this model, just to see what I explained before, I need an array that is a specific array of pictures. So in this case, what I'm doing, I'm creating another model that is described. It's like I'm using this model like a value object, if you're familiar with them. So I'm just describing what kind of elements I would expect there. Obviously, in MobX State Tree, I can also specify that some of them are optional. Therefore, I don't need to have them for sure. But leveraging this type checking at runtime is brilliant. The other thing, I have some action that will be called by other stores or some views in order to handle this thing. If we go back to our app, though I explained before that MobX State Tree allows you to work with composition, so I can compose my tree in different ways. And I'm doing that because potentially I could have multiple models that I would like to use. So this for me is just a way, yeah, probably I wouldn't do that in a real production code, but just to show you that you can do these kind of things when you work inside your application. In the main store, the Pix Gallery store, what we have is we are defining few elements that are empty, just initializing that. But there is a second element that we do when we create a tree. That is basically the environment. One thing that is brilliant about that, in particular when you work with multiple environments, and in my case, for instance, in my company, we're using 4 environments, is that you would like to have different endpoints, because maybe you want to have, I don't know, a different base URL for the endpoints or other stuff. So what you can do is creating what is called in MobX State Tree an environment, and you can pass a configuration where there you can wrap all your environment variable. And easily you can use them in order to do the things. So in my case, what I created, I just wrapped all the endpoints. And in this case, if I want to change or also test something specifically, I can do that easily just changing, creating multiple configuration and changing at this level here, injecting a new configuration. That's brilliant. So when we move forward and we start to look at on the store side, at the store side, what we have is we work with modules, basically. And what we have is like a main tree that is including all the modules. And we have a photo gallery store, we have a search store, we have selected picture store. I try to be granular because then what I can do is taking my view related to a specific store, take away and put in another project. So the whole point here is when you define your architecture is always thinking in a certain way onwards. Not too much, but you need to be, I don't know, if you're working in an agency and you know that that specific component could be reusable, maybe start to think how to let's say, create this component in a way that is easily extractable. You can easily extract from your main application. What we have here is a set of stores that is powered by MobX and State Tree. So if we start with, for instance, the search store, that is basically powering the text input. What we have here is several things. So the first thing is we created, again, my model. I'm saying that I'm searching or not. That's the first thing that I check. I create a computed value. That's an interesting one. So MobX State Tree is providing a couple of utils that you can have get parent and get env. So get env allows me to get the configuration, so pick up my URL in order to do a search. So in this case, I just take the environment and take the configuration, so I have access to my object that I described before, and I can start to interact with it. So in this case, I use get search URL because it's the URL that I'm going to use. And because I'm not going to change, MobX is providing a cached version, therefore I don't have to iterate on that part anymore. And then I have a few things. So every time that I'm basically doing, I'm typing stuff, I'm calling change search there. And then when everything is fine, I click the button search, I request the pictures, and then I do a fetch, I just retrieve the data from the endpoint. And when everything is fine, I'm just basically transforming my JSON in images, and I create how to do that. So I take all the response and I store in another model. As you can see here, for me, it's very easy to handle that because I decorated, as I said before, the pictures, the images are available for all the stores. And if I don't do the thing that I explained before with the gallery model, I had to remember in which store we collect all the images. So in this case, what I'm doing is literally having something that is available across all the different stores and passing that in a simple way like set pictures list or select picture. That is the first one that I'm going to use. Okay, so that's really it on the part of this store. So when we go, for instance, on the so let's go to first of all to the form and see how it looks like on the view. So in the view, first of all, we have the possibility to do injection of a store. So in this case, Again, MobX is taking care of everything for you. So inject in the store, so you know that it's there. You know that you are observing or any single change that could happen. And what I'm doing here is literally have my my button and my text field. And every time that I'm getting out from there and just saving the value, and when I click the button, I'm calling search. That is the request picture that we saw, the action that we saw in the other model. So when we move then to the photo gallery, the photo gallery is really minimal. So in this case, we have our gallery that contains our computed values that are the number of pictures. Obviously, if they are not going to change, it doesn't make any sense that I look for an observable. So I just use a computed value. And then I use actions in order to set the picture. So every time that I click on an element, I call this action, and that will basically get parent again. So it means that it's going to the main tree and set the picture. When I selected the picture, though, again, another really, really small store. So what I have here is I have my model that contains just an action. And when every time that I select a picture, I just update my main tree, and automatically that will trigger a reaction. So if we see briefly what we have in the grid is really simple. So we have our display of stuff. We retrieve data from the store. So you see when I have inject store, I can access it from the props. And therefore, you can access there. I can see which one I want. That is, in this case, photo gallery. And I retrieve the number of pictures. Fairly easy, nothing complicated. But as you can see, I completely separated. I want to move back a moment to the slides. I completely separated what is my business logic from the view. And this case is really helpful for me, potentially also changing completely the view, because the views are totally passive, and also dynamically, and move all remain with the same logic. Okay, that said, I spent, as I said, 2 years talking about reactive programming, and finally I grabbed all my thought and ideas inside this book. So I spent like 9 months working on it. So for the first 200 of you that are interested to buy it, there is this code that is 20% off on this book. And what I'm going to do is just talking about reactive architectures, and MobX is one of them, but you can find many others inside there, like Cycle, SAM, and other architectures. So thank you very much. I hope that you enjoyed, and if you want to reach me, you can find me on Twitter or via email. Thank you.